Yes, sir.
Okay, cool. Thank you for that. Let's continue. Okay. So basically, if you look at the Z distribution, we now sitting here with, they tell us that we need to look at with minus 2.08, which is, I think there is somebody. Okay, so everybody's in the room, nobody asking to come in. That is fine. So they're asking us the area under the standard normal curve that lies to the left of. So the left of is to that side. So basically we need to find out what is that area. Okay, so can you guys still hear me?
Yes, sir.
Yeah.
Okay, cool. Just everybody else just switch off their mics on their side as well, that we don't get all the funny noises coming through. So basically what we need to find is we need to find that probability. So in the exam, how I would look at it as well is, firstly, you can't get a negative probability. So that you can already take off. You can't get a probability that's bigger than 1. So option 1 and 4 is already a no-go. So basically we need to go and find what is the probability that that lies to the left. Now, even if you look at that, so remember there in the middle, we know that part is a probability of 0.5, and this part is also 0.5, so it's basically symmetrical.
John,
Yes.
can I interrupt?
Yes,
Sorry.
you can.
Does the question say we must find to the left or to the right? Because it says to the left is 0.100188.
Yes, so let's quickly see again. According to table 3A, the area under the normal left of that is, so they tell us what that is. Sorry, I haven't read the full thing. So they actually tell us that is 0.0188, eh?
Yes.
Sorry, I now misread that totally. I'm just going now into trying to solve that part. Sure. Without further consulting the table, the area under, okay, sorry. Thank you. You should have interrupted me quite earlier. Okay. So let's take that out. Let's take that out. Let's take that out. Let's take that out. Let's put back in that line. Okay. So basically they tell us that area is 0.0188. And they basically want what is that area. That is what they are asking. So they're asking the area under the standard normal curve that lies to the right of this. Sorry, I just should have read the whole question. So that also for the exam, please don't I just started off and assumed what they wanted, and I even didn't read the whole of the question. Okay, but still for the exam, so you could, doesn't matter now if you still need to find that out, you still can say 1 and 4 is not options because it can't be. Then if you look at, and let me try to draw that in again, if it's halfway, so this side needs to be 0.5, this side will be 0.5. So if you look at the area that you are looking for, it will be more than 0.5. So again, that one is not an option. Again, if you then look at that option, it should be more than 0.5. So that one is actually also not an option. So by eliminating, we got answer free. But the easy way to get that free is basically to say 1 minus the 0.0188. And that would have given you that number in any case. But nearly there's, in my explanation in the madness, it's basically to also show you how you can look at it from other ways and eliminate certain options. Yeah, so but again, don't do what Anna did at the beginning. I just assumed I need to actually work that out, and obviously it said something else. I just want to check if there is anybody that I need to include still. Okay, so everybody is in, so we can continue. Is that making sense, that one?
Yeah.
Okay, so okay, cool. What I also did is I just included so this to once again show you, and I should have included the other one as well, but it is just where you can find the value. So they said 0.008, so there it is in the table as well. So I think just again, because we're going to use this nearly for everything in the probability of a normal distribution. So between this and the t, you nearly need to know how to use it. The other one that I've seen guys talking about a lot on the group as well, and I quickly want to share where is the PDF of the workbook? Okay, so basically, I've now said in the previous one, the Z distribution is always a symmetrical distribution. So that is why for me, you can, if you look at that portion there, it's the same size as that portion there. So depending on what you need to find out, you can use either or of the two probability diagrams. And it's not about if it's a negative or positive, it's nearly to say which one is the easiest one for you to look for, and then you can use any one of the two. So if one of the questions is what is the probability that x is bigger than 2.9? So we're actually looking for that area, and we would have said what's the probability of 2.9. So we would have gone here and say, okay, the probability of 2.9, we're looking at it and it is 0.9981. But then we need to remember, okay, it's a small area, so we need to say 1 minus 0.9981. But actually, what's easier to do is that portion that you're looking for is already there. So if I just go to minus 0.9, there's my answer. So it's nearly to say, depending on what you're looking for, you can use the two tables. And I think that comes just out of practice nearly, that you pick these things up. And I think that is just one thing that I wanted to show you guys to make it a bit easier, that if you quickly need to do something, that you can quickly use one of the tables to get to the answer. Okay, so let me just share back again the other presentation, then we can go on. Okay, so question 15. A variable is normally distributed with a mean 10 and a standard deviation of 3. So they don't tell us n. So if they don't give us an n, we can use the easier formula of z is equal to x minus me over the standard deviation. So that is, if there's an n involved, then we need to go to the next set of formulas, but this is basically the standard one that we will use if there's no n. Okay, so and now we can just look at what they are. Okay, I see there's a few guys struggling to get in. So I hope they are getting in. Okay, so basically, let's look again. The variable normally distributed with a mean and standard deviation, and we need to work out what's the probability of x smaller than 17.5. Okay, so how I would do this is I would say, okay, I always will write that down for me so that I can just always go back to that when I need to look at the graph. So my probability needs to be smaller than 17.5. So I just say z must be smaller than 17.5 minus your mean divided by your standard deviation. Okay, so that is your probability needs to be there. So, and that basically then is that your probability of z will be smaller than 2.5. So it will be 7.5 divided by 3, which will give you 2.5. So if you then look at, and in all of these, I normally draw this just to make sure that I actually get the picture right. So z smaller than 2.5, so we know 2.5 is lying on this side. So let's say that is 2.5. So I'm looking for that area. That is the area that I need to get to. So if that is my area that I need to get to, I would use the table that gives me that. And that is not then this table, it would be the other one. So if I then use that table, I would go down to, and I haven't included it here now, but I would basically go down to where z is equal to 2. I would go across where z is equal to the 0.5. So that value then would give me the answer of 0.9938. And if I need to show it on the table, you can ask. Don't have an issue that if I must show you. So quickly give me a thumbs up if I must show you on the table. Because I think if you just won't get it, then it is. So anybody that I need to show it. Okay, cool. So let me That I just want to see if there's nobody waiting in any room. Okay, cool. So let's stop sharing. Let's share again. Okay. So basically, I was looking for the 2.5. So I would go down to where it is 2. I would go across where it is with 0.5. And why do I get now a different option?
It's 2.5 and not 2.05.
Ah, thank you. Okay. So where is my calculator? -17.5 minus 10 divided by 3. No, it is actually 0.5. 2.5. Oh, sorry. Yes. So there's the 2.5. Because it is 2.50, there is your value of 0.9938. Sorry. Yeah. So that is how you look for it on the table. So I actually did it a bit wrong on the screen. So I just would have gone down to 2.5. And then you would have gotten it there. Okay, and again, this is, so if you used this table, you could have again looked at the 0.0062, and you could have said 1 minus that would have also given you the answer. So again, I'm just showing you both because normally they give you both in the exam. So again, I think you will probably be able, I assume it's going to probably, this part will be open book for you guys, because I can't see them giving you formulas on one page and exam on another and working with dual screens and things like that. Yeah, it's gonna be a weird exam. I don't know how they're gonna really do this if you need to have the formulas and the formula pages and the tables as well. So yeah, so if they provide you tables, and if they only provide you one table, obviously you can get the other one in your textbook. But I just wanted to show you how to use both tables. And I think that is, I don't, if I again looked at your last assignment that you needed to complete, yeah, it's going to be a bit worried about your exams and how they want to do it. So, but hopefully we get more clarity over the weekend and then next week as well. Okay, so everybody happy with that? It is basically just the normal way to calculate it. There wasn't any difficulty really in it. Again, it is just don't make silly mistakes. I did now in nearly 2 questions. So that is just the important thing for me. So let's go to
Hi,
questions.
Jim.
Hi, how are you?
I'm fine. Just a question on clarity.
Yes.
Can I come in?
Yeah.
Yes, I want to check on question 15, because when you look at the 17.5, it says that area, it says less than. Are we not supposed to use the on table 3, the cumulative standard normal probabilities.
See, so and that is, I think that is the thing that don't let the less than in the question determine what table you're looking for. If you draw the diagram, this will automatically tell you to go to the table 3 on page 121. So
Yes.
so I would in the exam go straight for that. Don't even bother with looking at anything else. Go straight to that one. Yeah, so basically the drawing will lead you to which table you need to use. If it was that they said bigger than 17.5, so
Yes.
let's just for funny's sake do that as well. So then you would have needed that small area. So you could still have gone to table A3 and then set 1 minus the 0.9938. It will give you that answer. But then you could have also gone to this table, right? To this table and also have gotten the answer from there. So it all depends on what we're asking and what you need to do. But in the exam, go to the easiest option always. I think that is just, I'm just trying to give some other perspectives as well. But in exam, go to the simplest option. That's always always. And again here, if you look at things in the exam, so in a sense 2.5 can't be a probability, but here they nearly led you to what that is. So you would see a few times in some of your assignments as well, when they started asking you about probability and working out probability, most of the times one of the option is the Z that you calculated. It's not always like that, but it's nearly in every question there is this one value that is just bigger than everything that can normally be the Z that we're also referring to. Because again, it is sometimes you're sitting in the exam, you're working out, and you said, oh, cool, 2.5, got it. There's 2.5, got it. And you go to the next question. So again, I'm just giving some tips as well and things to look out for.
Okay.
Cool. So let's go to the next one. Question 16.
No, thanks for that clarity.
No problem at all. I think, please, this is the opportune time to ask these things that you don't. So anybody else also, when there's a question, we are a small group. So jump in and ask, please. That we just.
Okay, can I come in? Can I come in? Yes, I just realized that because the answer that we get is not negative, it's 2.5, meaning you are correct when you say I must also use the bigger portion, not the smaller portion. If I'm right, because if it was giving me a negative 2.5, that's when I'll consider that the table 3.
Yes.
Okay.
Yes.
Thanks, Chief.
Yeah. Okay, so the next one, and this again is, let's look at what they are asking. So a variable of a population has a mean of 100, standard deviation of 28. The value of a mean X for sampling distribution size of 49 is. Okay, so this for me is an interesting one. So what would you do here? So they basically asking us, let me quickly, population as a mean of that. So they want us to work out the sample mean. Okay, so they actually asking us, and let's quickly see where is that formula. So they want us to nearly work out, is it the sample error that they are asking us to work out? Variation as a population mean of that, standard deviation of that, value of a sample mean X for the sampling distribution of 49 is. This is quite an interesting one. Okay, so I want to erase that. I want to erase that. Can this be just as straightforward as I think? Okay, so we want the value of a sample mean. So if we sheesh, why do I just wanted to say it's 100? That okay, so I'll get this out of a textbook. Under this, I've made a note for myself here as well. So there's somewhere in the textbook, and not in the textbook, in the study guide as well, that and this is nearly a definition question, that the expected value of a sample mean is always the same as the population mean if I don't give it to you. So I will get that definition for you out of the study guide, or so normally that is how it looks like. So your expected value of a sample mean is the same as the population mean, and that is equal to 100. So this is one of those where they use the definition and they throw in all the other information, but it is actually just a simple answer. What caught me was also, I thought that I suddenly needed to work out standard error, and then probably there will be an option. One of these will probably be the standard error if I need to calculate this. But this is actually a definition question with extra information to basically confuse you. So out of the definition, the expected value of a sample mean is the same as the population mean. So I think that is one thing to nearly write down. I'll also type it in here when I update the slide as well. So, and I'll just check where that reference to that page is as well. Is that what you guys were also thinking, or what did you think you should have done here? Or was it one of those difficult ones that also caught you out? any feedback. Let's see. Yes, thank you. Yeah. So at least I don't know where that page reference is, so I will find it somewhere. Okay, thanks, Rian. Awesome. So
I think
again,
that's right. So
yes.
sorry, John. I think that's right. Just check the bottom of 127.
Yeah.
Yeah, that's right.
Yeah. See, and again, that is what.
Can you repeat the page number?
Page
127.
127. Yes.
Okay, thanks.
See, and that again for me is one of those that you don't. When I looked at this in now, and I was like, "Shoo, it can't be that easy. Why would they also give me all the other information?" And I think that's nearly trying to work with your brain to say, but it needs to be something different. So yeah, so I think this is one of those that you get with the normal definition kind of questions where they say something like the distribution, the probability adds to 1, blah, 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 those kind of things, but they can also nearly throw it as a curveball like in here. So yeah, unfortunately, but that is in the textbook or in the study guide. So perfect. So let's quickly go to the next one. Question 17. So now one must start looking at the things that they give us as well, and to look at first, and this is nearly the guidance also to say, we know when we're talking about small samples, you nearly want to say, okay, but I think we need to work with a t-distribution because that is like one of the options. But a sample of 16 observations is drawn from a normal population with a population mean and a population standard deviation. So if it's population standard deviation, we know it's Z. There's nothing else. We don't need to worry about the t. It's automatically that we work with a Z value. So in here, it is basically they want us to work out what's the probability of Z bigger than 1050 or not Z. What's the probability that X is bigger than 1050? So then it's basically again, we're using this formula, so need to get used to that one. But there is a sample size, so we need to divide by the square root of a sample size. So what I'm also just adding here is to say we are going to look for a Z value that is bigger than something. Okay, so then we basically fill in what is here. So we've got the X as 150 or 1050. Then we've got our mean as 1000. And under the line, so that already would tell us above the line it is 50. So under the line, we are sitting with standard deviation of 200. And we need to divide that by the square root of 16. So if we look at that, it's actually 200 divided by 4. And 200 divided by 4 is 50, which makes it equal to 1. So we need to look out for the probability where z is bigger than 1. So again, I'll draw my diagram. I think the other thing to realize is that in the middle is always 0. So we're sitting here somewhere with 1. They're asking us to find out what is that area bigger than 1. So 2 ways of doing it. So we could go to this table. 1 wasn't there, so I'll just quickly go to my table in my PDF. So if I go to the -1, I would get 0.15887. I still need to get my better equipment to write on this. But if you go to a normal table, the table 3 or A3, you could have worked out what that area is, and that area would have been equal to 0.8413. And then to get this area, you just said 1 minus that. And that also then would have given you 0.1587. Which is then that option. See, they give you that option as well. So I think that is also the important thing is they will give you the other option all the time. So that's why it's important that we from the start nearly write down, okay, we need to look at the bigger, we need to look at the bigger. If it's bigger, it is that area. That we nearly every time pinpoint that, because again, if you quickly looked at that table A3, you would have seen the 0.8413. You would have seen option 2, that is it, but it's not. Again, if you look where there's the 1, so they actually did again have a Z value worked out for you. So it seems like nearly in each of the questions it is there, but don't want to say it's every time there, but again, most of the times it is there. But this one, yes.
Sorry, I just have a question. Why are you looking at the negative values in that table?
Okay.
When Z is bigger than 1.
See, so, and the only reason I do that is to make it easy for myself. So if you, so let me, I'm gonna quickly, so let's quickly, I want to, and I think that is nearly, so let's do, so let's say that was the 1. And let's say that is the -1. And I think this, hopefully, just imagine everything is nearly the same. So that size is exactly the same at that size. So depending on what I must get to and what I must get to the quickest, I nearly decide between which table I want to use. So if you, again, that would be 1. So let's assume that is everything. So that's 1. That's 1. Let's draw this diagram a bit better, that it actually goes through very nearly. Okay, so to that side, 0.5. This side, 0.5. So that is where the symmetry nearly comes in. The same with that. So I'm nearly using the one that I feel for me can get me to the quickest answer. So if you would have used the table A3, you would have seen that was the 0.8413. And if you used the negative, you would have seen that one is the 0.1587. So because it's symmetry, this one is then the 0.8413, and that one is the 0.1587. So it's nearly, and I don't know if that is answering your question, but it's nearly, I'm looking for the one that makes my job easier to get to the answer. So does that answer your question or not?
I'm struggling to understand why, if you look for anything bigger than 1, for Z bigger than 1, why is that not 0.8413?
Okay. So let's draw it again. So remember, if you're looking at the Z table, in the middle is 0. Okay, yeah. So then somewhere here is 1. Okay, so they're asking us what's the probability that it's bigger than 1? So it's what's the probability that it's bigger than 1? So that area. So if you worked it out and they said, what's the probability that it's bigger than -1? Then it would have been a bigger area. So it's nearly, you need to look at your diagram of your probability diagram, and on there, it's nearly to say, okay, I need to find the probability that my solution is bigger than 1, and when it is basically that smaller area.
Okay, so the smaller area is the smaller value.
Yes. Okay. Yes. Okay. Yes.
That makes sense. Okay.
Yeah, and it's nearly, you can also look at how they, so the table that they use, or the table that they give the numbers to, they will also always have this as the diagram so that you can see. So that the area that's colored in is basically the area that we're referring to in the probability numbers. So again, the same with the other one, you would have seen, so that area would have been colored in with, so this area would have been a bigger number because it is referring to the bigger area. So but I think, and that's nearly the trick that you need to get with these ones, is that you need to know what you're looking for, because again, unfortunately, if you just read it off a table, you probably would have now said, I'm looking for the 0.84. because you were looking for one and you were looking at the bigger area. And unfortunately, in the exam, those options will be there. So that is why it's so critical to understand what you're looking for. Drawing the diagram that you get a better understanding where it is sitting really. Better understanding?
Yeah, that helps. Thank
Okay.
you.
Okay, rest of the guys also fine. So let's quickly go to another one. Again, question 18 is, what's that, a question or just background noise? Okay, so let's quickly again look at that one. So it will now be interesting for me how they would ask these kind of questions in your exam if you're doing it at home and things like that. But let's look at it. So assume that the population standard deviation is known. Okay. Population standard deviation is known. We use Z. To obtain a confidence interval for the population mean is reasonable to use. Okay, Z interval procedure, that is probably what I will look at. Two-tail procedure, I don't know if there even is something like that. It's not the T because we know the standard deviation is known. It is confidence interval, so it can't be one tail. They don't tell us anything about the sample, so it can't be that one, so it's nearly only that one. I don't even know if there is something like a two-tail procedure. We're looking at two tails and we're looking at one tail, but to call it a two-tail procedure, there isn't something like that. So we are working here with a Z interval, and that's basically just a definition question. What they are testing here is if you know that when they say population standard deviation is known, that you can work with a Z. So if a population standard deviation was unknown, then you would have gone to the T. And I think that is the only difference here is we know it is known, so we basically work with a Z value. Okay. So nothing funny in there. It was just straightforward kind of definition that we want us to work out. Okay, so let's look at the next question. A random sample of 40 regions gave, so normally I would just start off with say, okay, N is 40. I probably should read the question first, and they give me a sample mean of 6.88. Per 50 kilograms of watermelon. Assume that the population standard deviation, so that tells me we're working with a Z, is equal to 1.92. Oh, and they want us to work out the critical value. Okay, for the confidence interval of a population mean. Okay, so confidence interval, critical value, so we actually don't need to work out anything here. We just look at confidence interval at the 95%, and I think if you look in your study guide, there's that one table of if Z is a one tail or two tail at 90, 95, and 99%, what is your Z value? So Z here at 95%, I would have said that it is equal to 1,96, but I just want to make sure now. So let me go and check where that table is. I hope it was under the confidence interval.
Check page 158, I think.
Okay, cool. I like it that you keeping up to speed. 158. Okay, so 158. There you will get it, the two tail, one tail. At 99%, it is 2.58. At 95%, it is 1.96, and at 90%, it is 1,645. Okay, so basically we know that the Z is equal to 1,96, and that is option 4. Also interesting, I've assumed if you've worked with the T distribution, you probably would have gotten that number. I just assumed that. I'm not going to now confuse you with that as well. But this one actually, you don't need to work out anything. They're telling us the critical value at 95% level. So it is what it is. It is 1.96. Nothing in it. They give you a lot of other information, in a sense, nearly to try to trick you as well. And I assume this was probably at a stage part of 2 or 3 questions that they gave so much information. But this one, critical value, you look at the table and you get what you need to get. Okay, so I say it's nearly 5, but I want to at least do the next one as well, and then next week we can do the hypothesis testing. Okay, so question 20, let's quickly look at what they tell us. So I normally hate these ones because we need to work out the proportion. So in a random sample of n equal to 1,000, we found that the proportion of success be 48. So, and it is, I'm using this one, so it is 0.48, 95% confidence interval. So already there, again, we can use the 1,96 as the Z. So confidence interval for proportion is a bit more work in it. So it is looking at that one. We've got P1 minus P, and this is also where it, sometimes one can make a mistake in how you calculate this. So P we know is 0.48. So plus minus 1.96, and then nearly that I want to work out on its own, so that I can just say here times something. So on the calculator, basically it is 0.48 times 0.52, because you would say 1 minus 0.48. That you will divide by 1,000, so I get some ridiculous number of 0.00002496. But then I need to take the square root of that, and I am getting 0.001 0.157, and it goes on. And interesting. And then I would need to say, so let's just write that down here. So I hope somebody else is just checking my workings as well. So I need to multiply that by 1.96. So I've got 0.48 plus minus 0.0310 nearly. And again, as with some of the previous ones where they had Z as one of the options, look at that last one. So they give us the 0.48 that we're working with, and they actually give us, so it's not, you won't be able in the exam to just say, okay, that is what we need to work with, but it's nearly like there's normally something like this just to give you an indicator. Then we need to say, okay, the lower level is, or the lower confidence interval is the 0.48 minus 0.031. So that is 0.449. And then the top one is the 0.48 plus the 0.031, which will give us the 0.511. Okay, and then that is option 1. Yeah, so I think in this one again, it's not anything nearly difficult, but it is need to remember your formula. Probably will get it in the exam, or I'll also, like I said last time, I think I said it, I will write a few formulas down, but I'll also share what they normally give in the exam. And then basically you need to remember that you're working with 95% confidence interval. So the Z is the 1.96 that you're working with, and then it is just plus or minus the two numbers. Okay, happiness with that. Let me quickly just. Okay. Okay, so that was a few things that we covered today. So, and I think for your exam as well, I can't say it more difficult nearly, unless the other thing that they normally like to ask you. So I'll check for something like that in one of the previous papers. I've got, I think, back to 2012 nearly. So I've got a range of papers that I've got in print mode. So I'll just take one or two of them and see also what else is in there, to see if there's anything different in it. But this is basically nearly the questions that they will ask. So question 20, they could have had a very similar one like that for your normal standard confidence interval that you needed to calculate, instead of a question like question 18 or 19. They could have thrown in something like that, but hopefully we'll get to something like that still before the end of the time before you write exams. Okay, guys. That was a quick session. Again, I'll make the next Tuesday, depending on what you now hear your exam date is, we'll change up next week. So if I can't see you guys still writing, I think I had it somewhere 25 May or something like that. Yeah, I just can't see that that is still the date that you guys write. If it is still like that, then we'll do a few sessions next week and just squeeze it in everywhere during the week. But hopefully we get more time and then we can stretch it a bit. So as soon as anybody hears what hopefully the new exam date is, let me know. If there's no changes, let me know as well, and then we set up a few sessions for next week. But in any case, what I'll do next week, Tuesday, we do it again. I'll extend the 30 minutes one to an hour again, and then depending on what your exam date is, we'll maybe change some of the others. Okay, I'll try to do the saving to MP4 file again and things like that, and then we'll put it on the WhatsApp group as well. And again, if you're not on the WhatsApp group and you want to join, my number is 083-790-8387. Send me a WhatsApp and I'll add you to the group. Okay. Have a good evening, guys, and we'll chat again early next week, and hopefully we have at least some good news on exam dates. Okay. Cheers, guys.
Thanks, Gene.
Bye-bye.
Cool.
Cheers, John.
Cheers, guys.
Thank you.
No,
Bye.
keep well.
Bye.